Next is the modern joint application development, JAD. It was developed back in 1970 by IBM through a lot of success stories. It is considered as structured brainstorming. This is by IBM style, which is full of structure, defined rules, forms to be filled out. The joint application development technique is considered as an extended session to the workshop in the JAD session. Stakeholders and project team, they work together to identify the requirements. And the JAD is a more structured and intensive brainstorming approach. So it is considered as a brainstorming approach and also an extension to the workshop approach. So as a matter of fact, if you look to the JAD, is a combination of workshops, which we'll talk about it next, and brainstorming through multiple sessions. And those sessions would allow the business team to gather and to start to collect a large amount of information from the stakeholders. And there are several activities and even 6 human rules to be played in the JAD technique. And every JAD session may last a few days. As a matter of fact, it's normally 3 to 5 days. There are, as I said, 4 main principles when it comes to the elicitation approach using the joint application development, the JAD method. First one is effective use of group dynamics. It's just not one person. It's many stakeholders in one place. They do brainstorming and they do a lot of workshops. The effective use of group dynamics because it is used to facilitate and direct group sessions to get common understanding and universal buy-in. Also, what another principle of the JAD is it always use visual aids, and those visual aids are really good to enhance understanding by even preparing diagrams before the sessions. In the JAD station method, we always define processes. It's not a random thing. It's not just about confusing mix between different procedures in the process. Everything has to be defined. It's considered as a standard forms for documentation, for documenting the results. These are the main 4 principles that aligned with the JAD elicitation method. It's effective for group dynamics. It uses visual aids. It defines the process efficiently, and it uses the standard forms of documenting the results. The JAD itself, as a commonly used modern technique, it is used for making decisions on different aspects of the project as compared, if you compare this to for example, different other classical methods, we can't, like for brainstorming, as an example, it can be used to make decisions. However, the JAD, because we do have iterative sessions, in each of those iterative sessions, we have a deeply brainstorming. So by conducting those workshops with the sessions iteratively, we might be able to make decisions on different aspects of the project during those workshops. Also, any process where consensus-based decision-making, so it's not one person decision-making, it's a voting-based decision-making or consensus-based decision-making. Any process that is defined with a consensus-based decision-maker, it comes across function areas that are required, including planning a project, defining requirements, and designing a solution. These functional areas can be easily identified and summarized through the JAD elicitation method. Using the iterative workshops and sessions, it's easily to identify the process across those function areas using the JAD approach. Activities in JAD are 3 main activities. The first one is preparation activity. The second one is working session activity. And the third one is summarization activity. Keep in mind, it's just a workshop or just like a session. multiple sessions. And in each of those sessions, there will be a lot of brainstorming. So if you would like to perform a complete JAD illustration method, you need to do some pre-session planning, some pre-work, and then you do the working sessions, which is the real brainstorming. And then you will need to perform follow-up and wrap-up, which is summarization of the workshops or the sessions. Let's start by the first one, which is the first stage, which is a pre-session planning in the JAD method. Keep in mind that preparation is essential because it's an informal session. So for the standard one is informal. There are some formal sessions, but the standard one for the JAD approach is we assume informal sessions. And in the pre-session planning, you need to do preparation. You need to evaluate the project, in which you need to identify those issues and the scope of the JAD session, why this session is for. Also, you need to select the participants. Following that, you need to create some preliminary agenda of the session. And you need to determine the deliverables for the working session. And finally, you need to enable participants to prepare for the session. This is what you need to do as a pre-session planning. This is your homework before any session, any working session, any JAD working session. There are 6 P's that always align with JAD session. The first one is the purpose. Why do we do things? Means we need to identify goals, needs, motivation. You need to identify participants. Who is involved? People, roles, responsibilities. You need to identify the principles. How do we function? Using guidelines, working agreements, and even some ground rules. The final products. What do we create? What are the deliverables, decisions to be made, plans ahead, and the next steps? Places. Where is this located? Is it that means you need to identify the venue and the logistics. And finally, the process. When do we do what? Activities and sequences. Now, we did a pre-session. Now let's do pre-work. Pre-work, you need to, in a pre-work of any JAD session, you need to gather information. You need to clear a schedule for the working session, refine the session agenda, finalize the pre-session assignments, and of course, prepare material for the session, which could be some flip charts, presentation, and even if people are hungry, you may want to do some pizza. Now you did your job, breathe the session. What will happen during the session, which is the working session? You need to set up the stage. That means you need to welcome the participants, present tasks to be discussed, and of course, establish rules and mainly the on and off topics. You need to generate common understanding. This is where brainstorming come into place. You need to achieve consensus on the decisions. This is within the working session. Generate ownership of the results, create the deliverables, and this, as I said, using the standard documentation forms. Identify open issues and questions. Once the working session is completed, you need to follow up and wrap up. In follow-up, you need to resolve open issues and questions. You need to follow up on action items and reevaluate the project. If it's about to wrapping up right now, you need to review results of follow-up items to evaluate the JAD process and discuss what are the main lessons that we have learned. And of course, finalize the deliverables. There are 6 rules. So in JAD development sessions, there are 4 principles and 6 rules. So the 6 rules are the session leader, who is the organizer, facilitator, and the JAD expert, who has good expertise with the people skill, and he sets tone of the meeting. The second one is the analyst, who produces official JAD documentations, who is expert expert, a developer who understands the big picture, and also he's a good writer and organizer. The third rule is the executive sponsor, who is the manager, who has ultimate responsibility for the product to be built, and actually is responsible of providing strategic insight into the company high-level goals. And the executive sponsor is responsible of making those executive decisions later on as required. And the user representatives, that means a selection of acknowledgeable end user and managers. We call them the user representative. Actually, they come with a lot of suggestions and well-prepared questions and even idea of needs and elaboration. They will do a lot of brainstorming for the current or even for new and refined ideas. And eventually the user representative will review the completed JAD documents. And finally, the information system representative, who are technical experts on the information system and who are responsible to help the users to think big. They know what is easy, what is cheap, what is expensive. Also, they know where is mostly, what are the most informative chance to provide information to come up with accurate decisions at the later stage. So you can see in a JAD session, it's a session. We do a lot of brainstorming. It's an iterative process. There is a pre-work preparation that should be done. There is in-session work that you should be doing it. And finally, there is a wrap-up or a follow-up. And keep in mind, within all of the JAD sessions, there are always 6 rules with the 4 principles in place. JAD is a very good method in developing or in listing requirements. I think I missed one here. So I think this is number 4 and this is 5 and this 6. Of course, I missed the specialists who are the technical expert. And they're responsible of narrowing the topics. If there's an open-ended questions about security, the technical expert can help to narrowing down those questions or to provide answers that will help to narrowing down all the ideas that might be exploring the topic but might not be necessarily relevant because experts can easily answer them. So again, as I said, we have 6 rulers, the people in the JAD session. Each one has its own responsibility, his own responsibility or her own responsibility, and each one is a major active member in the JAD session to provide a final successful JAD session with required documentations, which means at the end, the requirements. Why we use JAD elicitation method? Because it provides the rapid decision making. So far, JAD is the elicitation method that can easily provide rapid decision making about the problem and also about the solution. JAD handles the rapid changeability in the requirements. It provides the well-formatted structure approach. It also provides the direct communication between all the stakeholders or the people of the project. However, because we assume that the JAD should provide the rapid solution, means at some point, it might be unable to provide the exhaustive validation in at least amount of time. So if you assume that the JAD session is 3 to 4 to 5 days per session, maybe you're gonna do 10 sessions. That means you only have like 30 days. So you do have a decision-making process has to be done in a rapid way, and a solution has to be established in a rapid way. So it's really hard to provide a validation in just like small amount of time. Also, to guarantee a successful JAD session, the JAD team will require to be very high level of expertise in the problem domain, which might not be the case. So these are the major drawbacks of the JAD. If we could overcome the fact that we hire people with expertise, then, and it's guaranteed, so this problem is solved. However, all the time, all the decisions that are made through the JAD session, it's really hard to validate. Maybe later we could validate it along the requirement elicitation process, or we could even combine it with some other elicitation method that can verify the brainstorming conclusions and information that were elicited during the JAD session. So another modern technique is the prototyping technique, and the prototyping technique more or less by using some mockups. Those mockups actually, as I referred to them before in the prototyping, if you remember the prototyping software development process, it's just a replacement of the entire software by a prototype. Prototype could also be used as a way for elicitation, which can easily support the requirement gathering process. And it's really good because when we introduce the prototype at the right time, you will be surprised how many requirements we can easily elicit. Mockups would help stakeholders to visualize the functionality of a given system. And actually, this can be an advantage to the business analyst and stakeholders because it allows them to identify those gaps and problems at earlier stages through the use of the prototype. This is a prototype in general. When we align prototype to a software, so the software requirement prototype is considered as a mockup or even partial implementation of the software system to help developers, users, customers, and better understand system requirements. It helps in clarify the complete it helps in clarifying and completing requirements. It provides early response to some of the questions about what I will know when I will see, this type of questions attitude. It is very effective in addressing yes, oh no, but some those undiscovered tones. Also, it helps find new functionalities and discuss usability and of course, established prioritization of the requirements. Prototyping is considered as an effective way in resolving some uncertainty that can be easily found in the early stage of the development process. Prototyping focus on prototype development on these certain parts. And also prototyping is good because it encourages user participation because once you build a prototype, you will always provide it to the user to retrieve feedback. That means it's easy to obtain mutual understanding. Prototype could be of any form. It could be a paper prototype, like storyboard or even prototype on index cards. It could be screen mockups or could be interactive prototypes, either by using high-level language or by using a script language or even by using animation tools. Prototype could take a model, could take a form of models, or even could be a pilot system. Prototyping, although it could be of different shapes, there are different types of prototyping. The first one is called horizontal prototype, which is mainly focused on one layer. You could have a prototype, but just building a user interface. Or it could be a vertical type, which means you actually have a slice of the real system. Or it could be a evolutive prototype, which actually tuned into a product incrementally, gives users a working system more quickly. So it begins with requirements that are more understood. Evolutive prototyping is intended to deliver a workable system quickly to the customer. And that means the requirements, which should be supported by the initial version of this prototype, will be considered as those requirements that are well understood and which can deliver useful end user functionality. It's only after extensive use that poorly understood requirements should be implemented. So the evolutive prototyping model, it turned into a product incrementally, and it always begins with those requirements that are well understood. You never build a prototype with requirements that are poor understandable. And the last type of prototyping is called the throwaway prototype. It is considered as less precise model. That means we thrown away just a model. It focuses on the less well-structured aspects of the system to design. And the prototype is only designed to elicit or validate requirements. The throwaway prototype is intended to help elicit and develop the system requirements. It doesn't give you a product. It just helps in elicit and develop the system requirements. And the requirements that should be prototyped are those which cause most difficult actions or difficulty to the customers and which are in fact the hardest to understand. So at this point, it's a little bit different from the evolutive. For the evolutive prototype, we understand the requirements and they are easily understandable or more understandable. So we built a prototype that can be easily incrementally updated. However, the throwaway one, it's less precise because it only used to elicit and develop system requirements, and those type of requirements that we're going to use it to build such prototype for the requirements are considered as the hard to understand. Those requirements that are well understood need not to be implemented by this type of the prototype. So in throwaway prototype, we build the prototype for the hard requirements. For the evolutive, we build a prototype for the easy requirements. There is a property, we call it fidelity. So the fidelity, it's always aligned with the prototyping elicitation method for requirements. The fidelity is defined as the extent to which a prototype is real and especially reactive. It may vary from the thrown away prototypes. So even through one or more throwaway prototypes, we could have different level of fidelity. We could either have high level of fidelity in which we understand that application that works is very close to the real system. Often it involves programming or executable modeling languages. Those prototypes that are really close to the real system. When we align to requirements, it means that it's really close to the real requirements. Advantages of high vitality prototypes, because it provides an understanding of not only the functionality of the prototype, but it also reduces the design risk, and they are considered as more precise image or verdicts about requirements. However, for building a high vitality prototype of requirements, it takes a lot of time. That means it's really costly to build. Sometimes it's difficult to change. And also it gives a false sense of security because it often focuses on details rather than the goals and those important issues. That means there's a more or less full sense of security because we are not providing a lot of details. We're just trying to build something that is close to the real thing by ignoring the goals and important issues. So the sense of security is not actually achievable in the sense that the high vitality prototype would be acceptable, although it enjoys the fact that it reduces some risk regarding the design and understanding the functionality, but this is a major drawback of high vitality prototypes. On the other hand, for the low vitality one, it's not operated. It is static. It's easy. It's considered as easy and quick prototype for requirements. Because it's easy and quick, it is cheaper to develop. It's very good for interfaces. It's excellent for interfaces, and also it offers the opportunity to engage users. And this could be a reason why we use those low fidelity prototype, because it really encourages the creativity by involving users. It's not close enough to the real system and it's not operated, it's static. So it's easy to be used for interfaces. And that means we have a great chance to engage users before even the code would start. However, although it's good for interfaces, but it may not cover all the aspects of interfaces. We know that it's not interactive. It may seem non-professional in the eyes of some stakeholders. It depends. So although it's recommended to start by low fidelity prototypes for the interfaces, and then maybe at some point you convert your prototype into a high fidelity, is still a trade-off. At which point or in the project you would prefer to to elicit requirements using prototyping, whether it's high fidelity or low fidelity. Whether prototyping, although it's really good, there are some risks and problems associated with prototyping, including some drawbacks when it comes to only the focus on interfaces. Because at this point, we lose, if just the focus is about interfaces, we lose the focus of the functionality. Prototype can bring customer expectation about the degree of completion completely unrealistically up. It would increase the customer expectations to the level that might not be even the real case. Also, don't end up considering a throwaway prototype as part of the production system, because it always clearly states the purpose. It's always important to clearly state the purpose of each prototype before building it. Always we have training costs associated with prototyping, especially in the development phase of the prototype, because it requires some special purpose tools. The development cost, so in addition to training cost, there's also development cost, which depends on the prototype being developed. There are extended development schedule. Developing a prototype may extend the schedule itself. Although the time of the prototype actually may be recovered because the rework is avoided, but still it adds up to the overall development schedule. Some issues that we might see in prototype, which is the incompleteness, because it may not be possible to prototype those critical requirements. So non-critical requirements can easily be modeled through a prototype. But for those critical system requirements that cannot be prototyped or mocked up, we consider this as part of incompleteness, which is a major risk with the prototyping elicitation method. Following prototype, the workshop is another elicitation technique. It's just about conducting workshops. So workshops contain group of users or the stakeholders. They're working together in order to elicit and gather and identify requirements. Our requirement workshop is very structured to capture those requirements. And in workshops, we mainly discover, define, and prioritize the requirements. And this is for the system to be developed. They are considered as the most effective way to deliver high quality requirements in a very quick way. They promote those mutual understanding and a strong communication between users or stakeholders and the project team. When you have iterative workshops, that means you have iterative sessions with a lot of brainstorming. This is where the JAD elicitation is defined. Finally, the reverse engineering. From the word is we reverse the engineering process to elicit requirements. So this elicitation technique is generally used in migration projects. What does this mean actually? It means that if we do have an existing system that it has outdated documentations, we could actually reverse engineer this project. And the reason for this, because we could easily understand what the system does. This is an elicitation technique that can easily extract those implemented requirements from the system. In reverse engineering, there are two types of reverse engineering techniques. The first one is called the black box reverse engineering, and the second one is called the white box reverse engineering. In black box reverse engineering, in this system, we study the components of the system without examining its internal structure. That means we are not examining the functional or the composition of the software. On the other hand, for the white box reverse engineering, the inner working of the system are actually studied. That means we do analyze and understand the software code. So these are the main types of reverse engineering. Either it's a black box where the system under consideration is studied without examining its internal structure, or we actually examine the internal structure in the white box reverse engineering by providing detailed analysis and understanding of the code. In this tableau, I'm sharing with you a comparison of the data gathering techniques across different dimensions, including when they are good for different data types, the pros and cons, like advantages and disadvantages of each of those types. So if we start by questionnaires. So for questionnaires, it's good for answering questions that are specific, and we guarantee that it's easily to elicit requirements through answers of those specific questions. Data types of questionnaires elicitation method could be of either quantitative, so we have numbers like data, numerical numbers, or it could be qualitative, just text. Advantages of questionnaires: it can reach as many people with low resources. It suffers from the fact that this design is crucial. You have to design your questionnaire in a way that is really attractive, and at the same time, it collects most of the requirements that are needed. The response rate may be low, so at this point, you might not have all the requirements needed, and the responses may not be what you want. You just assume that everybody would answer questions that you were expecting them to give answers for the requirements you would like to elicit, but it just turned out that those responses ended up to be not what you want. On the other hand, interviews, it's good for exploring issues. Mostly qualitative data through interviews. It's just about writing. After you meet with the during the meeting with the stakeholders, you collect information simply through writing, but we could see some quantitative numbers or some quantitative requirements. It's really good because interviewer can guide the interviewee, and it encourages the contact between developers and even the users. It suffers from time consuming. It considered as artificial environment may actually intimidate the interview. The decisions and the answers might be influenced. Also, we have the workshops. Sometimes we call it focus groups. It is good for collecting multiple viewpoints. Mostly qualitative. We still have some quantitative data types collected. It's good because it highlights area of consensus, like we have majority votes, and conflicts. Also, it encourages the contact between the developers and the users. However, if there's a dominant character, there is a possibility that we might have a dominant character and that might affect on the decisions. That's why it's important to be unbiased. Also, observation. It's good for understanding the user activity, including the context of the user activity. Most of the data that are collected are qualitative, and it's good to observe actual work that would give insight about the requirements that was not easily to be elicited by other techniques. Keep in mind that nature observation is very time consuming. Also, huge amount of data are collected that need to be analyzed. Finally, documentations, either for existing system or by providing document analysis. It's good for learning about procedure, regulation, and standards. Most of the data collected are quantitative, and it doesn't need time commitment from the user. However, it needs day-to-day work because it depends on the documentation procedures and the structure and the format of and the size of the documentation provided. So this, like in today's lecture, I have covered traditional or classical elicitation methods and then some other modern elicitation methods. I have also highlighted on the advantages and disadvantages of each one of those methods and when to use them when there's a need to use them. You could use one or you could use one or more. In elicitation, requirement elicitation, there is future research directions in the field of requirement engineering because although there are many techniques have been investigated so far, however, many other investigation topics are still in place, especially the tools for requirement elicitation, also cognitive support for requirement elicitation, intelligent tools for requirement elicitation, and even those methods that involve direct interaction with the stakeholders. If you are interested in requirement elicitation, you may see a lot of research areas around the increasing awareness and education of analysts and stakeholders in industry. Some research area are currently in developing guidelines for techniques selection and even managing the impact of factors on the process. In addition, investigating ways of collecting and reusing knowledge about requirement elicitation, integration and use of new techniques, including agent-based and web-based architecture. This is the recent, we call it the next generation of support tools in requirement elicitation. Also, now we do have many case studies in industrial experience report on how requirement elicitation could actually contribute to the success and failure of projects. Some future direction that you would consider is to understand or to explore how requirements activities could relate to each other and even could relate to new and developing fields. In addition to software engineering, you might be interested to go over web-based systems, agile development, or even some machine learning approaches. So this is the end of today's, of this week lecture, and thank you for listening.